All right, so using that same example and even using those same marginal revenue and marginal cost curves, now we're going to talk about how the monopolist makes their quantity and pricing decision and how we illustrate the profits therein. So we're going to be using that same marginal cost curve. We're going to include a new curve here that is going to be our average cost curve. So your book, the other thing too, it's a little inconsistent. Your book does not say average total cost. And this is actually pretty consistent with a lot of the resources online. So you're going to see AC a lot, average cost. That's the exact same thing as average total cost, okay? So I'm going to stick to saying average total cost because that's how I learned it. And I think greater amounts of specificity are better, right? Because average cost could be, in my mind, could be variable cost, could be average fixed cost, right? So for me, it makes sense to put the extra T in there to really specify it, that it's the average total cost. But again, you're going to see it as AC in your book, and that doesn't refer to Assassin's Creed, right? So in order to do our profit maximizing rule, we have to get our demand and our marginal revenue curves in here. So we remember that our demand and marginal revenue curves both start at the same point. Our demand curve is a flat line that's downward sloping. And let's see, this demand curve has a slope of 2 down and 1, 2, 3, 4, 5, 6 across. So that's a slope of what, 1/3, rise over run. And so this marginal revenue curve, if I want to create it and have it be true to form, should be twice the slope of the demand curve, which means it should fall 2 and go over 3 instead of going over 6. So again, our marginal revenue curve always has twice the slope of the demand curve, and it always starts in the same exact point as the demand curve. So now that we have this situation here, now we can, and I'm going to just change things just a little bit just to make things slightly less on top of each other. Okay, it's not perfect, but it's still better. So where are we going to produce, right? Doesn't matter if we're perfectly competitive. It doesn't matter if we're a monopolist. We're going to produce Q star where the marginal revenue is equal to the marginal cost, right? We know that's our profit maximizing rule. So we find our marginal revenue, we find our marginal cost, and X marks the spot. We drop a little anchor. And again, the reason why I use, anchor and everything like that is there's a method to my madness here. It's because a lot of students, when they find this point, they've conditioned themselves by working in the perfectly competitive world so much, they find this point and they say, this is the Q and this is the price, right? This is nothing. This point right here is absolutely nothing. It's not the price. It's not the cost. So that's why I'm saying drop an anchor. And then, now that you have the equilibrium Q star, then I want you to ask yourself, if I was the monopolist, how much would I charge? I'm going to charge as much as I can, right? And how much is as much as I can? That's going up to the demand curve. So despite the fact that not despite any fact, the monopolist is just going to charge as much as they can. So at that particular quantity, they're going to go to their presumed demand curve, and they're going to find whatever that price is that they're going to be charging. And so in this particular example, it looks like the price is $800. And when we have these graphs, right, it's important to sometimes slow down and to be like, okay, what are the different sections of the graph, right? So for this one here, right, this is going to be my total revenue rectangle. And we know that my total revenue is nothing more than my price times my, I probably shouldn't use star there, times my quantity. And so this particular case, we're told that the quantity is equal to 5. So this is going to be 800 times 5. It's going to be $40,000, Warhammer 40K. And so the graphical representation of that is this whole giant rectangle here. Does that make sense to everyone? Because total revenue is equal to price times quantity. We're literally just making a rectangle with the price and with the quantity, right? With that price, with that quantity. And then that's creating a square, which the area of which is equal to our total revenue, 40K. Now we're going to do a similar thing with our costs. So we're going to say our total cost is equal to what? Our average total cost times the quantity. And so we are told that at 5, our average total cost looks like it's 400. So 400 times 5 is going to give us 20,000. Just to give us all a little bit more clarity in terms of where all those numbers are coming from. And so this rectangle here is going to be our total cost rectangle, right? That rectangle there, the area of which is 20,000, tells us that the total cost is 20,000. Now, the part of revenue that is not cost is known as our profit. And this is going to be my giant total revenue square minus my hopefully smaller total cost square, so that I get a profit square up top. Now the other way we can think about this is it's equal to total revenue minus total cost. We know the total revenue is price times quantity. We know the total cost is average total cost times quantity. We have a like factor in both of these terms. So in the same way that when we have 7x minus 5x, or that's actually not a great example, huh? Oh no, that is a good example. 7x minus 5x, this like term here, right? So we can pull that term out and we can turn this into x 7 minus 5, right? So in a similar way, we're going to pull this q out here and do qp minus atc. And so that's going to be our profit equation. And again, we represent profit with pi in economics, which is frustrating once you get to macroeconomics because we also represent inflation with pi. But I didn't make the rules or the abbreviations or the shortcuts. So profit is equal to the quantity times the difference between the price and the average total cost, right? And we know that the price is this guy. We know that the average total cost is this guy. We know that the quantity is this guy. So it's very clear from both my drawings here, but also from the mathematics, that this rectangle up here is going to be our profit rectangle. And we can calculate the numerical value of this two ways. We can, again, subtract total cost from our total revenue, 20K minus, or 40K minus 20K, which gives us 20K. Or we can take our price, subtract our average total cost, which is 400, so P minus 800 minus 400 is 400. 400 times 5 is 2,000, right? So we can calculate it two different types of ways. It should give us the same result no matter the way that we calculate it. Since the price is above the average cost, the firm is earning positive profits in this particular example. Any questions on illustrating profits with monopolies? All right.